Hey everybody, this is Larry. This is me going with Q4 of the biweekly contest 50, minimum number of operations to make strings sorted. So this is, to be short, hit the like button, hit the subscribe button, join me on Discord before I forget. And yeah, so this is just a very hard problem. There's no way about it. I recommend you watch me solve it live during the contest. You can fast forward, skip ahead or whatever, but I'll have it after the explanation. And the way that I did it was, and I think I left my code in there, which is that I generated the brute force solution and then try to figure out a pattern. And the math here is not as interesting because it's just about figuring out the pattern. But the idea is that a key component about this problem is just trying to rephrase the problem in a way that you can implement the code. So here, let's say, we're going to go over the property of this problem, right? So that here, we're basically one at a time. What this algorithm or these operations try to do is one at a time, starting from the end, keep everything sorted. And yeah. And so then here, we start with Y and Y sorted, so that's good. Now we insert the D, that's also sorted, so that's good. Now we have ODE, right? Now we have to sort this. And the way that this gets sorted is by, okay, first the O becomes, and I'm explaining it without any proofs. You really have to just figure out the properties. Like I said, if you watch me solve it live during the contest, I actually like wrote down all these things and try to figure these things out manually. So then what happens is that it converts the O to a D, to the next letter that's smaller than it. So it converts to E. And then now it's trying to sort the rest, which is O and D. So it's trying to sort the rest into D and E. D and O. And then now the next one, the E is going to be to the next letter, which is D. And then now it is going to be sorted in D, O. And then now this thing is sorted. And then now we add in the next letter, C. So C, it looks good because C is already sorted. And then now the next letter is T. And then here's the suffix. We want to sort this into the next letter, as I said. So it's going to be O. I don't know. It doesn't matter what this is, but it just sorts it into this. And yeah, and then the next letter after that is E. So C, D, O, T, D, C, E, O, T. And then now at the very end, it sorts it into this. Cool. So that's basically the idea. That's the pattern, that you sort it one at a time in these ways. And then that part is hard to figure out as is, because you have to figure out the second part of, well, how many operations does it take to sort a suffix? Well, it turns out that it actually is just the total number of combinations with those characters. So in this case, because all the characters are unique, it is going to be 4 factorial, because they're 4 factorial. So it takes here from here to here 4 factorial, from here to here is 4 factorial, and then so forth. And then it gets a little trickier when you have to do when there are duplicate letters. But it's still the same concept. But let's say we had, which one was the one? I have something like this, I think. Yeah, so then first it does B, second B, A, second A. And then now it has this, and then it tries to get to this, the next letter, B, A, B, C. And the number of, and actually it starts, I think, by the reverse. So the next one after this is actually this, and then you want to sort it into this. And the number of operations that it takes, it's actually just this formula of 4 factorial over 2 factorial times 1 factorial times 1 factorial. And I don't know how, and this is a very common combinatorics counting thing. So I'm not going to do the proof here because the proof is a little bit tricky. I think what I would recommend as a prerequisite is just doing more combinatorical problems. And this is a common numbers that should stick out to you when that happens. So yeah, and once you're able to do this, from here to here, and then now the next letter is just A, A, B, B, C, C, and then now you're done. So yeah, so that's, oh wait, no, this, so C, oh yeah, and then this goes to A, B, B, C, C, oh no, A, sorry, this, and then now you have the second C to add, so then now you have this, and then it goes to, you know, and then A, B, B, C, C, right? And of course, in this case, this would be, you know, it would take 5 factorial over 2 factorial, 2 factorial, 1 factorial. So that's basically it. And my implementation is this, and I don't think I'm going to go over it that deeply because it requires a lot of, maybe there's an easier way to do this, but it requires some power and math with respect to modular inverse, which I'm not going to go over either because that's, you know, these are things that are kind of what makes this problem hard. And yeah, I mean, these are things that you have to, or for this problem, I would recommend learning it from other problems before you are able to tackle this one. And yeah, and basically everything follows after this pattern. After I discovered this, I basically just implement this pretty quickly, except for I had a minor bug that took me 15 minutes to debug, so it really tanked my ranking. But yeah, but I'm happy that I solved this without any errors. So yeah, so basically just going really quickly, though, but I'm not going to go into that many details, just going over the problem. So this is, you know, just setting up the problem. This is just me pre-calculating the factorial, you know, given the mod, and the modular inverse given the mod. And then here, you know, for each character that we add in, we keep track of a counts table, which is just basically the count of every alphabet, which is 26. And then for each, and then say this is a C, we look, can we change it to a B? If there's a B, then we can change it to a B. And then we keep on going downwards that way. Here we use this character. We calculate what we said earlier with respect to the factorial times the product of the modular inverse. We mod that, and then yeah, and then we add that counts back on so that it can be, you know, use the next one. And that's pretty much it. And then this is just to keep track of the number of characters that we used. We kept it in another way, but that's fine. But yeah, and then at the very end we return the mod. Yeah, and this is what I had on brute force to kind of check my answers on a couple of cases, smaller cases obviously. But yeah, let me know what you think. I actually go through my thought process as I was doing this during the contest. Maybe not 100% clear, but you can kind of see my thought process as I do it, so I definitely recommend it. So what is the complexity, right? Well, for each character, you know, this is going to be O of n loop, and this, of course, will just be at most O of 26, because 26 square, alpha square, which is the number of characters in the alphabet, because for each character we look at all the previous characters, which is 26, and then we do this thing which is also of 26. We could have probably done some math in some funky way, but we didn't do that. Like we probably could eliminate this loop, but it was not slow enough, so I didn't really have to worry because this is only 3,000. So yeah, it's going to be 3,000 or n times alpha square, which is fast enough for this problem. Cool. That's all I have. Watch me solve it live during the contest. Maybe it'll help a little bit. Like I said, don't feel that bad if you don't get this one, because I don't think there's a lot of components that you need to know, and it's very mathy. Every component is pretty mathy. So I don't know. I don't think it's going to come up on an interview anyway, unless you're doing some like crazy quant stuff. So I wouldn't worry about it that much. But it is a fun problem. Hope you enjoyed it. And yeah, I will see you later. Yeah, watch me solve it live during the contest next. Keep forgetting it recently. largest I. Largest I. 2. S of I is less than. Okay. So this is B and A, or just A. Say what? This is impossible to understand. Okay. The examples don't make it really that much better. J, okay, so largest index I, so that's B. It is one index, 0 index, now that's A then. Such that 2 is less than B, okay. So that's A. J is such that, I mean, J has to be 2 at this point, but swap I minus 1 and J, okay. Reverse that string. Don't know, I know this one's impossible to read, let alone solve. Okay. Example here, I is 3. And then, okay, so the biggest number, that's 4, so that's 4. Okay, then we swap up A and B, and then reverse the string started at 3. Some sort of weird insertion sort. So what is this doing? It takes the first instance of an inversion, in this case, well, the latest inversion, so it'll be OD, it swaps. Has to be strict. Largest index J. What does this mean? all the numbers are... Okay, so then it's the first instance where swap I minus 1 and j. Index I. I never know how to do this. This is wrong. Can't even write trivial code correctly. Why? That one seems fair. What? Why? I always... I can't even get this code right. BAC, so then now B and I should be Z, I should be 1. Why is it not 1? Oh, I see. Okay. So far. I mean, we don't expect this one to be right, but that's fine. See. Okay, so now we have to correct code. Just gonna be taking way too long. Yep, 63, 5263. Okay, so then now we can see what Leetcode is doing to Leetcode and see if we could skip steps. Okay. And people solved it yet? 2 people solved it. Let's see. I mean, this is some like weird bubble up sort. How many people got this? Very smart people have gotten it. Figure out the pattern. So this is sorted. So now that the suffix is sorted, what happens? It goes to the next one, which is 19. Let me even just look at the third example. 63. This may be a hint actually. 2 to the 5th times 2. Alright, let's look at that one first, actually. Sort the last 2, okay. And then and what happens when you have a new number? So everything after that should be sorted. Right, so now we look at B and we have to try to figure out so these 2. Okay. Now we factor in the B. I mean, the number of inversion isn't just n square, because this is already bigger than n square. I'll look at it from the back, but I don't know that I can get anything from that. It's like a weird insertion sort. What does this do? What does the reverse do? I'm trying. What does adding the t? So this looks at the next suffix, just these three. Can't find any property with this that I can figure out. This suffix is done. What happens when you see a new letter? It takes DAP, swap the P and the D. So then now that means that this will be sorted but reverse. And then the reverse sorted, we're trying to get it back to the front, and the ticks, I don't know. But then now this is sorted. C looks at C sees D, so then it needs to do the prefix of. So then it does BAC. And then it just does stuff until this is sorted again, which is 24 moves away. 4 factorial is 24. And then it does it for, and then B, and then now we know that it can do that. Move the A to the front. So then now you have these things, which is 4 factorial again, which means that this is 24. Is that right? I guess that's right. So it takes n factorial to sort the thing. And then now we can bubble sort maybe. So now we take the p. Okay, I mean I have some intuition, but now I struggle a little bit. So now A and then D has to go to the next character. I think I get the idea, but I don't know what the answer of this is, of course. But okay, so now we find O and D, and then now we sort these. Which is already done, so we move this to E, and then we move this to a D. So the C is good. Wonder if this actually runs. Okay. Just good that we have this a little bit. Yeah, I'm closer. Now I have to figure out how to get it. Oh. And I have to figure out how to handle dupes. Oh. So moving this to a Y would require let's take the suffix. Looks good. Add a D. It's sorted, so that's still good. Add the O, it is not sorted, so then it ticks. Four moves. Is that right? Because the first move is moving the Y and then moving the D. So it's 2 factorial times 2 factorial. And then now we have to sort it. C is sorted, so that's okay. And then the T will go from the O, which is in theory, this should be 4 factorial. And we go from 4 to 28. And now we move it to the Y. Which is plus 24, yep. Okay, let's see. I have an hour. How many people have gotten it so far? People are really smart and fast, it seems like. I need inverse math for this. Maybe. Okay, I have to figure out one more. Oops. Yeah, that's what I expected. Roughly, it's 4 factorial over 3 factorial. I always forget how to do modular inverse. Okay. Really? Oh. Okay, that looks roughly right. Forget this by accident. So we assume everything after this is sorted. Then now we take the count. No, that's not right. What I want to do is, okay. Look at okay, we have to look at the next one. So for x in and then now we want one. That's not good. Oh, I don't add. That's not right. That's right, but then the math is wrong. No, this should be. No, this is wrong. This should be. How do I do the math? Because then now we're swapping with x, and then we want actually. Half right. That's wrong. Good start though, but 340. What is the answer here? 320. So I'm probably off by a little bit of a constant. Let's try something dumber. We should be able to solve this, given that we have a lot of time, but still tricky. I need to do this locally, so that doesn't give me this stuff, but okay. Why does that the case? So I think, so my math is that it is fewer. That's too hard to print out. Something about the uniqueness, that's why I'm a little bit, oh, I was wrong. Why is this particularly? Maybe I just need to suck it up and figure it out. Is this work? Okay, so it is definitely something with the duplicate letter handling that I'm not handling well. I'm trying to reduce the case a little bit. Oh. That's good, maybe. Let's have a good freaking case. Okay, so with the go. Oh, it's good. So C is good. C. So the first thing we're going to do is actually T and C. So then now it's trying to figure out how to do this. T going to O is well, it's 3. It's 4 factor. Well, it's 4 maybe. But I thought it is 6. So that's not right. It's T going from So just to get an O is here. So we have TCCO to sort out. I don't know. Okay, no, this is an O. Okay, I'm looking at the wrong thing. This is an O, so we need to sort this thing, which in my math should be 4 factorial over 2 factorial. So that's 12. And here we go, 13. Right? And then here 13, it goes. So C, we're trying to sort this out. So that's going to be, again, 4 factorial over 2 factorial, which is 12. So 25. Okay. So far, so good. And now this is an O. So to sort this thing out, it's going to be 5 factor. So that's 30. So 55. I mean, I think my math is right, so my implementation is a little bit off. Okay. Oh, that's awkward. Now 1, 2, 3, 4. That's right. 18 is after it does all this, which is definitely not right. So okay, so dun, dun, dun. This first 4 is fine. Yeah, and then now this is 4. Yeah, that looks like that would make sense. Nope. Okay, so now this is saying C goes to 1. Gets what the hey? So it should be 20. That seems right. So now see, that's right. So plus 12. Bad math on the whatever is side. Yeah, I mean, this is right. It does have the 12. And then it goes another 12. Another 6. Oh, this is another 12, but oh, I am dumb. Okay. And this is the bad time for my computer to be running slowly, but oh, come on, so close. Okay. Oops. Oh, come on. Of course, now is the time that it is choosing to be slow. My computer gonna cost me some points or whatever. Oh. There we go. My Chrome always fix the worst time to be whatever. Why is it pending? Oh, come on. Come on, old computer. Oh, because it's printing a lot. Okay, that looks like the right answer. Let's run it again. Now without the printing code. Okay, it still has some printing code. Please. Cool. Whew, that was tough. I mean, I don't know how other people did it. People are very smart in doing these maths, but I hope you enjoyed that. This video. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Hope you did well in this contest, this problem. Let me know your questions. Yeah. So take care of yourself, take care of others, stay good, stay healthy, and to good mental health. I'll see you next time. Bye bye.